Let's work through a materials variance example problem. So the problem says that Ramsey Company purchased and used 2,500 pounds of materials during March. They spent $15,000 on those. Then it says their standard cost of materials per unit produced is based on 3 pounds per unit at a cost of $4 per pound. And production in the month of March was 1,000 units. So we need to compute the total price and quantity variances for materials. But before we find those, let's first just define our terms, right? Our actual quantity, actual price, standard quantity, and standard price. So our actual quantity, how many actual pounds did they use of materials? 2,500 pounds. Actual price. We're going to want a price per pound. So we take the $15,000 that they spent on all of their materials this month and we divide it by the number of pounds that they purchased. So 15,000 divided by 2,500 gives you $6 per pound. Now standard quantity. Going into the month of March, based off of our standards, based off of our expectations, what would we have expected to use in materials? Well, we expect 3 pounds per unit. So if we're producing 1,000 units, we go 3 times 1,000. So we would have expected to use 3,000 pounds. Now standard price, that's just the $4 that they give us. So now we can compute the total price and quantity variances for materials. So a few different ways that we can do this. Let's work through it visually here. So we have actual quantity times actual price over in the far left. In the middle, actual quantity times standard price. And then in the far right, standard quantity times standard price. Well, if we take the difference between actual quantity times actual price and actual quantity times standard price, we get the price variance, right? Because the only variable that changed in those two boxes was the price variable. So, between actual quantity times standard price and standard quantity times standard price, the only piece that changed was the quantity. So the difference between those two amounts would be our quantity variance. Then we can take our price variance and our quantity variance, find the difference between those, and that's our total variance. So let's plug it in with the numbers that we have. So actual quantity times actual price, 2,500 times 6 gets you 15,000. Actual quantity times standard price, 2,500 times 4 gets you 10,000. Standard quantity times standard price, 3,000 times 4 gives you 12,000. So we can first find our price variance. So 15,000 minus 10,000 gives you a price variance of 5,000. And then we have this U. That U stands for unfavorable. So what makes this unfavorable? Well, our actual price was more than our standard price. So going into the month, we thought that we were just going to have to spend $4 per pound. We actually spent $6 per pound. That's not good, right? So that's what makes it unfavorable. We actually spent more than what we expected to spend. Now, we take actual quantity times standard price of 10,000 and standard quantity times standard price of 12,000. Take the difference of those and we can get our quantity variance of 2,000 favorable. Now what makes this favorable? Well, we were able to produce 1,000 units with less pounds of materials. We expected going into the month that we were going to need to use 3,000 pounds if we were to produce 1,000 units. We were actually able to do all of this with just 2,500 pounds. So we used less materials than what we expected, giving us a favorable quantity variance. So now we have a price variance of 5,000 unfavorable and a quantity variance of 2,000 favorable. Since they're different signs, right? One's unfavorable, one's favorable, we take the difference. So our total variance here will be 3,000. 5,000 minus 2,000. And since the price variance had more unfavorable than our quantity variance did favorable, we keep the unfavorable sign on our total variance.